Welcome to this first video in the screencast series, Computer Vision, a crash course. In this series, which is divided into 5 videos, we're going to learn how to do image classification using a simple machine learning model. In the first video, which we're currently looking at, we will experiment a bit with images to understand how images are represented in Python and NumPy, and using the Pillow library to visualize them. We will also learn about different color spaces. In the second video, we will set up the environment. This will be a very short video because we're using Google Colab, so all the environment is basically set up. What we'll need to learn is just how to integrate it with GitHub and how to upload files to the Colab server. In the third video, we will explore the dataset. We will use the digit recognition dataset from sklearn. And in the fourth video, we will use this dataset to train a model, a support vector machine, that we can use to classify the images for the digits 0 to 9. And we will also see how we can use the built-in functions in sklearn to evaluate the model. And finally, in the fifth video, we will see how we can make predictions on our own images using the model we have trained. So the idea with this course is that you should be able to fulfill it within a day. So let's get started. When we talk about images in Python, and especially in NumPy together with Pillow, we see them as three-dimensional arrays. As you can see in the image here, we have a two-dimensional image which consists of 3 different channels. These are the red, green, and blue channel. And this order is true when working with the Pillow library for visualization. But you should be aware that other libraries might have different order. For example, if you work with OpenCV together with NumPy, you will see that they use the opposite order, BGR, blue, green, red. So when talking about the images, we have 3 dimensions. The first dimension, dimension 0, is the vertical dimension. It goes along the rows. From row 0, which is the topmost row, to row height -1, which is the bottom row. The first column, or the second column, dimension 1, is the columns. So this goes from index 0 to the left to index with -1 to the very right in the image. And finally, we have the channels, which is the third dimension, or dimension 2. And here we have index 0 for red, index 1 for green, and index 2 for blue. So what if we would like to address all the pixels in the red color plane in the top left half? We could do that by specifying a range of pixel values for each dimension. So in dimension 0, we would address index 0 to index height divided by 2. In dimension 1, we would address index 0 to width divided by 2. And in the third dimension, we would just index 0, which is the red color plane. So let's get a bit more practical and dive into a Colab notebook and test this out. So the first thing we're going to do is that we're going to go to colab.research.google.com. If you haven't already used this, you can log into your Google account, which enables you to store the files on your drive. For now, I'm just going to press New Notebook, and this will give us a blank notebook. So it's unnamed. Let's name it to Play with Images. And the first thing we will need is an image to actually play with. So let's go to Google and we search for sunny landscape. I'm going to take this image. So I just right-click it and copy image address, which gives us the URL to the image. Next thing, we're going to actually download it to the notebook server. And we can do that by executing a Linux command by starting with an explanation mark and doing wget, and then posting the URL. This will now download the file for us. We can run another Linux command, ls, to list the files, and we see that we do indeed have the library here, or the image here. So the next thing we're going to use is the pillow library. And we're going to use the image class in this library. With this class, we can open this image file. And this is all we need to do to visualize an image. So this visualization is built into Google Colab. So if the return value from a statement, or rather the return value from the last statement in the cell, if that is an pillow image, then Google Colab knows how to visualize this image for us. So this is something that we can use to visualize the images that we are working with. So we're going to save this as pillow image. So when we're working with images, we would like to have them as NumPy arrays. It could be depending on what we're doing, but especially for machine learning, we typically see the images just as arrays instead of actual images. So we can do this by converting the pillow image. We're going to import NumPy. And we just convert the pillow image to a NumPy array. Now we see that we get an array with lots of different values. So we can also in the shape of this array. And we see that it's 756 pixels height, 1600 pixels width, and 3 pixels in depth. So this is the channels. There are red, green, and blue channels. So how about if we have an image as a NumPy image and we want to visualize it? So this is our NumPy image. If we want to visualize this now, because this doesn't mean a lot to us, then we can convert it back to a pillow image. By using the fromArray function. But we also need to specify the mode of the image, or the color channels. And in this case, we know that it's an RGB image. So that is 8 bytes for the red, 8 bytes for green, and 8 bytes for the blue. By doing this, we will get the same image back. If we would instead specify L here, which is the mode for a grayscale image, then we will get an error, because we have 3 dimensions in the depth, or the depth is 3, but a grayscale image should just be 1. This is the way we can convert images from pillow images, which can be used either for visualization or for drawing on images, to NumPy images, which we typically use in machine learning, and then back to a pillow image to visualize it. So let's do some changes. If we want to address the top left and change the color values of it, we can do that in the NumPy image. So after creating the NumPy image, let's address the different rows. So from row 0, which is implicit, we could write 0, 2, but we can also leave it out. Actually, first, we want to know the height, the width, and the number of channels. In height, we're going to address 0 to height divided by 2. And in the width, we're going to address 0 to width divided by 2. So this will give us the top left half, or the top left quarter, rather. And we're going to do this for all the color planes. And we set it to 255. Let's execute this and then visualize the image. We see that now it's completely white here. So why did we set it to 255? That is because our NumPy image has a D type, which is uint8, unsigned 8-bit integer. That means that we have the values 0 to 255. So 255 is the maximum value, and this is represented as white, while 0 is represented as black. So let's just do this for one single color plane. Let's do it for the red color plane, the 0 index. And we set this to 255. Now we see that we get it kind of pink. So why doesn't it get red? It's because we still have color information in the 2 other channels. So we could set the channel 1 to end, so that's channel 1 and 2. We set those to 0. Now we will get a red rectangle. And likewise, if we instead set the red, green, blue, so number 2, which is blue, to 255, and we set 0 to 0, so no red and no green. We could also do it like this. Now we will get a blue rectangle. So if we just want to set the topmost row to white, or to set it to pink, so we set the 0 index, the red channel, and we set row 0 and all the columns. Now we see that we have a pink 1 pixel wide line in the top. And if we want to do it on the left side, we instead set all the rows. We set the 0th column. And now we have a tiny pink line on the left side. So what more can we do with images? Let's remove these alterations to the image, so we get the original image back. And let's now say that we want to detect the sky. Where's the sky in this image? So we can do this by assuming that the sky contains much more blue than the other parts of the image. So we can create a binary mask by taking the NumPy image, and we just want to look at the blue channel. So all the rows, all the columns, and the second channel, or index 2, which is the blue. And we want to say that if this is more than 127, so that it is more than 50% luminant, this will give us a binary mask. With the same shape as the image. So we could use this to address the image itself. We say all the pixels in the image where this is true, we set them to 255. And then we visualize the image again. So now I have made the sky totally blue. So let's reset the image again. And let's look at what a grayscale image is. So if we take just one of the channels, all the rows, all the columns, and the blue channel. Now we have an image which is just 756 height, 1600 width, and no depth. It's just a single channel. So this is typically what we call a grayscale image. We could also get it by averaging all the layers along the, or values along the third axis. Or we could get it by weighting them differently, which is typically how you generate a grayscale image from an RGB image. But in this case, let's just use this blue channel. We have the blue channel as a NumPy image. If we want to visualize it, we need to use the pillow function to convert it to a pillow image. But if we just run this now, we will get an exception because it's not an RGB image, it's just a grayscale image. So we can do that by changing to the mode L, running this again. And of course we should not have shape there. This should be the actual NumPy array. Now we have a grayscale image. And we can also do resizing of the images. So let's save this as blue image, and then we do blue image dot resize. And let's resize it to height divided by 4 and width divided by 4. So we do it 1/4 the size in each dimension. And this function actually takes the opposite order, the width and the height. So here we have to scale it down by a factor 4 in each dimension. So this was the basic crash course in working with images in Python. Stick around for the next videos in the series where we will learn how to set up the environment, learn how to understand the data sets in sklearn, and learn how to actually classify images and do inference with the model we have trained.